Well, good morning. Thank you for inviting me into your classroom to talk to you about water. Allow me to introduce myself. My name is Kevin Hemp. I'm the water guy. I work for this company here, CV Water District. And we all know what CV stands for, right? Yes, Coachella Valley. So I work for the Coachella Valley Water District. And before we talk about, this is for fifth grade. Before we talk about our fifth grade topics on water, we're going to focus on the water cycle, our local water resources, things of that nature. Before I begin though, there is a term that we throw around a lot in the water business, and I'd just like you to be familiar with it because I may use it from time to time. So let me introduce you to that term. The term is acre foot, and an acre foot is a unit of measure. It's how we at the water district measure water. So what is an acre foot? Well, in those two words, you're probably more familiar with the word foot. A foot is a ruler, 12 inches. We call that a foot. So we know that. But how big is an acre? Well, an acre, if you bought an acre of land, it would be roughly the size of a football field. So when we say an acre foot of water, what we're saying is we're going to take a football field and we're going to flood it with water to how deep? 1 foot. Yeah, 12 inches. And that is what we call 1 acre foot of water. So if you measure that in gallons, that works out to about 326,000 gallons of water. So if you hear me say acre foot, that's what I mean. So continuing on with this idea of acre foot, let's look at a body of water here in the valley in terms of acre feet. Okay, the Salton Sea. Okay, the largest lake in California, only happens to be about 30 miles from here, contains 7 million acre feet of water. Okay, how many football fields is that? If you said 7 million, you're correct. And I just want you to understand, if I say a big number like that, like 7 million acre feet of water, you can kind of picture that in your mind and you can say, oh wait, it's 1 for 1. If he says 7 million acre feet, that's 7 million football fields. It's the same comparison. So, okay, enough on that. Let's jump into the presentation. Now, I like to begin the fifth grade presentation with what I call the big picture. And the big picture when it comes to water is the earth. Now, this might sound like a dumb question, but what is all that blue stuff that covers the earth? If you said water, you are correct. And so in fifth grade, I understand that you study percentages. So let's break the earth down, the earth's water down into what we call a pie chart. It's a graphic representation of different percentages. So what we're going to do is we're going to color the earth in blue, everything that represents water. Okay? And that would be 70%. So 70% of the Earth's surface is covered with water. Now, percent is based on 100. So if percent is based on 100, we have 70 pieces of the 100. Where are the remaining 30? Land. So we're going to represent that here. So 70% water, 30% land covers the surface of the earth. Based on this pie chart, which is there more of on the earth? Is there more land or more water? Obviously, there's more water. So with that in mind, let me just say this. I was giving this presentation to a fifth grade class one time, and somebody asked, how much water is there in the world? And I have to say, I didn't know. So I did some research. I went to a website called usgeologicalsurvey.gov. And the scientists that run that website believe that the earth contains this much water. It's 978 trillion acre feet. How many football fields is that? Yeah, it's 978 trillion. That's more than we can even conceive of. But, you know, just for fun, if you want to see an even bigger number, if we convert that into gallons, Do you want to see how many gallons that is? Because I think we understand gallons better than acre feet. So if you convert that into gallons, you're going to multiply. How many gallons in 1 acre foot? Do you remember? 326,000 times 978 trillion gives us this crazy number. 326 quintillion gallons of water cover the earth. So I know I'm not very good at math, so I really don't understand that number, quintillion. But I did some research on it, and here's what it would look like if you wrote it out. First off, to write out this number, 326 quintillion, you would have to start by writing the number 326, and then you would follow it with 18 zeros. Wow. Yeah, that's a lot of water. And now I did break it down into place value to help us get our head around it a little better. So let's take a look at that. So starting from the right end of the number, we have our hundreds, we'll call them. Then we have our thousands. Then we have our millions, billions, trillions. I don't think I ever go higher than trillions. Does anybody know what comes after trillions? Quadrillions, and then yes, quintillions. So it's a tremendous, tremendous amount of water, more than we can even imagine. To try to put it in perspective, if you could take all the water in the world and divide it up equally among all the people that live in the world, each person in the world would receive a portion of water the size of Lake Tahoe. Now, if you've never seen Lake Tahoe, here's a picture of it. Obviously, it's not a picture of the whole thing, it's just a piece of it. To really appreciate how big Lake Tahoe is, I have a little map here in the right-hand corner of the screen. And the map shows us that Lake Tahoe is a very large lake. It's 22 miles long, it's 12 miles wide. It's 1,600 feet deep. And so there's enough water in the world for everyone in the world to own their own lake the size of Lake Tahoe. That's pretty amazing. And another fun fact, if this water was yours, if you had this all to yourself, there's enough water in Lake Tahoe to last one person for 700,000 years. So why am I saying all of this? Well, I'm trying to make a point. And the point is there's a lot of water in the world. I mean, even more than we can imagine. But with that said, unfortunately, sadly, we have a water problem in the world. What? A water problem? How could this be? We have so much water in the world. Well, the problem is not how much water we have, it's the quality or the type of water we have available to us. The problem is most of the water in the world is salt water. Nothing really wrong with salt water except if you try to drink it. If we as people try to live on salt water will actually kill us. The salt that's in seawater or ocean water will actually suck the water out of our bodies and we'll die from dehydration. So that is a problem. Turns out most of the water in the world is undrinkable because it's salt, has salt in it. To help us see this, again, we're going to look at another pie chart using the earth as a template. And this time we're going to color in red everything that represents salt water on the earth. Okay, are you ready? Here we go. 97%. Of all the water in the world, 97% is salt water. Means it's undrinkable. Is that a problem? Yes, it's a huge problem. Now remember, percentages are based on 100. We're at 97. How many pieces of this pie chart do we have left? Yes, we have 3. So 3% of the Earth's water is fresh. And that's what we need. We need fresh water. The water that we drink must be fresh in order for us to live long, good, healthy lives, right? We need fresh water every day. Now, this problem gets even worse if you consider that we're going to break this 3% down even further into 2% and 1%. And the 2% represents the fresh water that's frozen. It's actually inaccessible. Places like Antarctica, where you have ice shelves that are 2 miles deep in some cases. Fresh water, yes. Do we have access to it? No, we do not. So in reality, what's that really leave us with? More like 1% available fresh water. Yeah, so it turns out the water we need the most, fresh water, is available to us the least. But there is good news to this. And the good news is that in nature, we have this amazing system called the water cycle that actually recycles this fresh water supply around the earth every day. And so it's constantly moving and it's an inexhaustible supply. We constantly have this moving of fresh water around the earth through the water cycle. And that happens through the power of the sun. Basically, when the sun heats the earth, it warms not only the soil, but it also warms the water. And in this case, our sun is warming the ocean. And as the water in the ocean here, as a liquid, warms up, something happens. It changes form. It changes from a liquid to a vapor. And it actually goes up into the sky in an invisible process. You cannot see it. A process called evaporation. And the water that evaporates into the air, it collects in the air, high up in the atmosphere. And then it condenses. You can actually see it. And when you're able to see it, we call the visible water in the sky a cloud. And the clouds are formed through a process called condensation. Now, here's the amazing thing. In this picture, we just took salt water from the ocean, power the sun, converted it into fresh water in the air. So what happened to the salt? Yes, the salt was too heavy. It actually stayed behind in the ocean. And the fresh water separated and ended up in the cloud. So now we have this situation where we have water in the air constantly circulating around the earth. The clouds are carried around the earth by the wind. And the water that's in the clouds falls back to the earth. Yes, in a process called precipitation. So the fresh water falling back to the earth, precipitation, can take on several forms, actually 4 forms I'm thinking of. Let's take a look. Precipitation can be rain, which in the desert we're probably more familiar with than, say, this one. This is snow. It doesn't snow a lot here in the desert, but snow is precipitation. Or it could be what we call sleet. It's kind of a mixture of rain and snow. It's kind of slushy. Or it could be, the most dangerous kind is hail. Hail, if you've ever been caught in a hailstorm, it is not fun. It's not like being caught, like when it starts snowing, you kind of run out there and you try to catch the snowflakes on your tongue or something like that. You do not want to do that with a hailstorm. A hailstorm, they're stones of ice actually fall from the sky. They conk you on the head. They can probably do a lot of damage. So you want to run for shelter from hail. But these are the different forms of precipitation. Now, in our picture here, all of this precious fresh water, if you look, is falling back into the ocean. You're like, we need that fresh water. Let's bring some of that fresh water onto the land where we can actually put it to good use. And so if we bring the clouds onto the land, as that fresh water falls onto the mountains, you can see what happens next. The fresh water starts to run down the sides of the mountains, and the hills and the mountains, right? And the process of water running off the mountains, we have a really fancy term for that. It's called runoff. Yes, and so water runs off the mountains, and you can see that in our situation here, or our picture here, is running off back to the ocean. And so this is why this system is actually called a cycle. Cycle is a Latin word. It comes from the word cyclus, means to go around. That's where we get the word cyclone from. Like a bicycle, the wheels go around in the same way all the time. So here we had water from the ocean go up into the sky, fall back to the mountains, and then back to the ocean, and it made a circle. So that's why we tend to call it a water cycle. Or if you want to get really fancy, we call it the hydrologic cycle. Yeah. Okay, so let's take a look at runoff. Runoff can look like a lot of different things. Here's the picture I choose to represent runoff. It is a mountain stream. And if you were out hiking in the mountains and you came across a stream like this, you may stop and consider it, just ponder it for a moment, ask yourself, where is this water coming from? Well, it could be coming from several locations. Again, let's take a look. It could be runoff from rain. Now, it may not be raining where you're standing, but it could be raining further up the mountain, and that rain is hitting the mountain and running past you. So it could be from rain. It could be runoff from snow melt. Now, snow accumulates high up in the mountains. When it gets warm, the snow melts, and it makes these streams also. So it could be runoff from snow melt. Or it could be runoff from what we call a spring. A spring occurs naturally, and it's when water kind of springs up out of the ground. It kind of just jumps out of the ground. And springs, I must say, here in the Coachella Valley are common. In fact, I can think just off the top of my head, 2 cities that are named after springs here in the Coachella Valley. I'm thinking, yes, Palm Springs and Desert Hot Springs, yes. So it could be from a spring. Or it could be from all 3 at the same time. You really wouldn't know unless you followed it all the way up to its source, and then you could see for certain where that water is coming from. So when we see runoff, we may not know exactly where it's coming from, but we definitely know where it's going to, right? Because water always runs downhill. Now, these streams from runoff actually tend to join other little streams, and they make bigger streams that we call rivers. And the biggest river close to us is the Colorado River, which some of you watching this have probably been there. It's a great place to go boating and fishing and swimming and things like that. But the Colorado River is runoff, mainly from snowmelt from the Rocky Mountains. And it's a major water source for us here in the Coachella Valley and in Southern California. So the Colorado River is runoff. It actually runs down through several states, actually 7 states it runs through, and Mexico. And here we actually intercept it at a place called Lake Mead or Hoover Dam. So you can see there is a concrete dam there on the Colorado River. We intercept that water from the river, and that water accumulates and forms a lake we call Lake Mead. And we use that for storage. So we store the water in Lake Mead, and then the water is released from around the dam, goes back into the river, and continues on its downward journey until finally it goes into Mexico and finally enters the Pacific Ocean down in the Gulf of California. And so that's kind of a long way of saying we started in the ocean and we ended in the ocean, and thus we made a cycle. So that was another way of seeing that. Now we probably could just end it there, but since we live in the Coachella Valley, and there's this part of the water cycle that's very important for our water supply, I thought it'd be good to look at this other portion of the water cycle. So I'll try to not go too long on it. But that, hold that thought, step back. Here's the big picture of the water cycle. There it is. So we can see all of the elements of the water cycle working together, going around and around, to move that 1% of available fresh water around the earth every day by the power of the sun. Okay, back to my other point. The part of the water cycle I would like to focus on now, which connects us to the Coachella Valley, is percolation. Percolation is a part of the water cycle where some of the runoff does not make it to the ocean. In percolation, some of the runoff actually soaks down into the soil, down into the ground. And that's of huge importance to us here in the Coachella Valley because our main water source in the Coachella Valley comes from percolation. And to better understand this, let's take a look at another picture. Okay, so here's a picture of the Coachella Valley. Now imagine that the snow you see in the mountains there, it melts off, it runs off, it comes down to the valley, and some of that water actually soaks down into the soil through the process of percolation. The water that percolates down into the soil accumulates underground and creates a massive water supply that we call an aquifer. You see a number down there, it says 39 MAF, that's million acre feet. So the water in our aquifer, estimated storage, 39 million acre feet. Fresh water, by the way. So how many football fields is that? Yes, 39 million. So just so that we understand each other, when you turn on your sink at your house here in the Coachella Valley, that water comes from the aquifer. That is our source of drinking water. It is very good, high quality, clean water, naturally filtered by the sand and the gravel, and it is drinkable. We do test it to make sure that it meets all standards for clean drinking water, and it is okay to drink. But I just wanted you to know that when you turn on your sink in the Coachella Valley, that's where the water comes from. It comes from the aquifer. Okay, let's take a look. So there's our snowmelt, there's our runoff. Got another number there. We have 62,700 AF, acre feet. That's our average amount of melted snow runoff into the Coachella Valley each year. Okay. We also get water into the aquifer from rain, about 3 inches per year, not very much, but we'll take it. Every little bit helps. We try to get that rainwater into the aquifer as well. The rain that we get, the snow that we get really is not enough to supply the water needs of the people that live here. So as a water district, we bring in more water through these pipelines. If you look at the picture there, there's a number, it says 194,100 acre feet. That is the water we import through what we call the State Water Project. And to understand the State Water Project, we're going to have to take a step back and look at the whole state of California. So, state of California, big state. We're the third largest in the 50 states. And turns out that we're such a large state, the rain does not fall evenly across the entire state. 80% of the precipitation, the water falls from the sky in California, falls in Northern California. 80% of the rain falls in Northern California. Why is this a problem? It's a problem because most Californians live in Southern California. Southern California, if you live here, you know it's dry. It's a desert. Okay, so where there's a huge demand for water in Southern California, but the water is up north. So how do you solve a problem like that, where you have water up north, but most of the people live in the south? The way California has tried to solve the problem was back in the 1960s. The state of California built this integrated water system called the State Water Project. And this diagram here kind of shows a general outline of that system. I actually included another separate project, but I put it in there because they are tied together and they are somewhat related. So let's take a look at California's water system that can take water from the north and send it down to the south. Okay, we're going to start off with the highest blue oval there. I colored it in red so you can see it better, but That water system is a federal system, and it's called the Central Valley Project, or the CVP. And it actually starts at a lake way up in Northern California called Shasta Lake, or Lake Shasta. And Lake Shasta, when it's completely full, holds 4.5 or 4.5 million acre feet of water. When water is released over Shasta Dam there, it goes into the Sacramento River. And then if you follow the red line, that's the Sacramento River. It goes down to the middle portion of California. And I lightly colored in a red portion there. I don't know if you can see it, but that's where this water is served in what we call the Central Valley part of Northern California. And that's used mainly for farming and for cities and the like, and people that live in that area. Now, for us here in Southern California, our interest in this system begins here in the blue area. This is the beginning of what we call the State Water Project, or the SWP. And that actually starts at a lake here called Lake Oroville. Lake Oroville holds, when it's full, holds 3 million acre feet of water. And so what happens is water spills over the spillway there at the lake, and it goes down into a river. You can see at the bottom of the screen. That river is called the Feather River. The Feather River continues down and then connects to the Sacramento River. So together, the Sacramento River, the Feather River, they feed together, and then that water continues down to a place that we call the Delta. The Delta is kind of like a water wheel, if you will. It's called the water hub of California. It's where water collects. It's an interesting place, very unique. It's mostly marshland. A lot of it's below sea level. There's water going every which way. You have water coming down from the north. You have water coming up from the ocean. You have places where the fresh water meets the salt water and it mixes. Very interesting place, the California Delta. But in the Delta, where the water is still fresh, there are pumps. And the pumps suck the water out of the Delta and then pump it into this portion of the State Water Project here. It's called the Aqueduct, the State Water Project Aqueduct. And it's a huge, long canal aqueduct. It's 444 miles long. And it goes from the Delta, which is kind of around the San Francisco area, all the way down south to Southern California, to a place that is not very far from the Coachella Valley. It goes to this little lake here called Lake Paris. And Lake Paris, it's a little lake. It holds 132 TAF. That's actually 1,000 acre feet. 1,000 acre feet. So why did I say all of that? I said all of that because here in the Coachella Valley, we have a right to state water. We pay the state of California for rights to use this water. And the closest place for us to get this water from is this little lake here, Lake Paris. This kind of creates a problem, though. Let's take a look. So if you look at our map, you see that blinking area down there at the bottom portion of California. That's us. That's the Coachella Valley. And now, if you look right across, you see the little lake. You see Lake Paris. It's about 60 miles from here. And the water that we bought from the state of California is sitting in Lake Paris. But there's no way for us to get that water. It's just sitting there. So what to do? Well, we could build a pipeline. We did not build a pipeline because it was too expensive. If we were to build that pipeline today, it would cost us about $2 billion. So our board of directors kind of scratched their heads and they said, well, what else could we do? How can we solve this problem? We have rights to this water, but we have no way to get it here. And the solution we came up with is connected to the Colorado River. Let's take a look. So putting California in the larger context of the other states, the southwestern United States, The blue line there coming down through the center of the screen represents the Colorado River, okay? And you can see it actually runs along the southeastern border into California. It actually separates California from Arizona. Well, it turns out there's another water district in Los Angeles called Metropolitan Water District. And a long, long time ago, way back in the 1930s, they actually built their own pipeline to get water from the Colorado River to the city of Los Angeles and other areas. And so on our map, here is that pipeline. We call that pipeline the CRA, stands for Colorado River Aqueduct, okay? It's 242 miles long, and if you notice, it goes right through the Coachella Valley. How convenient. So, what our board of directors did, they talked to Metropolitan Water District of Southern California, and they said, hey, let's make a deal. We have water sitting in Lake Paris. We have no way to get it. We will give that water to you. In exchange, you give us an equal share of water from your pipeline that was running through the valley. And they said, deal. And so the area of Los Angeles takes our water from Lake Paris and they put it to use. And then in exchange, they give us an equal share of water from the pipeline. And they turn that water out here in the Coachella Valley. Let's look at it again. There it is. You see the 4 pipes there. There's 1, 2, 3, 4. Those make up what we call the CRA, the Colorado River Aqueduct. So when those pipes are open, this is Colorado River water that spills into the Coachella Valley. It flows down into the valley. Now this is up near Palm Springs area. It actually enters a natural river in the valley that you may be familiar with called the Whitewater River. It flows into the Whitewater River, and then the Whitewater River takes this water and steers it down through the valley. It travels under the Interstate 10 freeway, continues down, flows down and under the railroad tracks, and then continues on down for a total distance of about 4 miles, and finally ends up here at a percolation site. There's that word, percolation. All of this is connected to percolation, okay? So this water flows down into this percolation site outside of Palm Springs. And we collect the water here, and the water actually percolates. It actually soaks down through the little particles of sand and gravel and rock, and it goes down and is collected in the aquifer to be stored for later use. So that's kind of that system. Very interesting system. There are 4 major percolation sites in the Coachella Valley. I'd just like you to be familiar with them. The first one is this one right here. This is the largest one. This is the one outside of Palm Springs. We call it Windy Point. There's 19 ponds here. We're looking at a satellite image. That means it's taken from outer space, looking down. And if we're having troubles understanding what we're looking at here, this is a very large portion of land. It's 2 square miles. And there's 19 ponds here. In fact, if you want to count them, here they are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 ponds. Okay. Now, if you want to see how big these ponds are, let's compare the size of the ponds to the size of a house. So if you look in this there's a little red circle there in the kind of like the lower left portion of the screen. I put a circle around a house, and then I drew a line to one of the ponds, and you can see the size of the house compared to the size of one of the ponds. These ponds are very large. They're massive. Okay. So these ponds collect water, percolate it into the aquifer. That's the first site. The second site, same general area. This serves the city of Desert Hot Springs. It's actually operated by another water district in Palm Springs called Desert Water Agency. And this is Mission Creek groundwater replenishment facility. And then we have one in what we call the East Valley. It's kind of like in the South La Quinta area. This is called the Thomas E. Levy GRF, Groundwater Replenishment Facility in La Quinta. And then our newest one, we just opened up last year, is right here in the middle of Palm Desert. And this is what we call our mid-valley groundwater replenishment facility right here in Palm Desert. So these are areas where we're actively percolating water back into the ground. Very important areas. So there we are again. There's our big picture. We see all of the portions of the water cycle, including percolation, and we are almost done. So let's jump into, though, talking about our 4 sources of water here in the Coachella Valley. As I list these, I'm not going to put them in order because I already talked about some of them. So I'm going to just cross them off the list as we go. First one we can cross off, we already talked about, is SWP water, State Water Project water. We use that for percolation. Okay, so cross that off, check. Second one, well, actually the first, groundwater. Now I could check this off. We use groundwater for our homes and for businesses. But before I check it off, I just want you to understand how we get the water from the aquifer to your house. And here's what that looks like. So to get the water to your house, we have to drill a well. We drill a hole into the ground. And at the bottom of the well, there is a filter. It actually screens the water, keeps all the sand and the dirt out. And then that fresh water pours into the well, and there's a pump that when the well is operating, when it's running, it actually pulls the water into the pipe or into the well, and then that water can go, you can see it actually can go to 2 places at the same time. One, it can go to your house, it can go to your home, or it can be pumped uphill to be stored in a huge round steel tank. We call it a reservoir. Okay? Now, once the reservoirs are full, the well turns off. And when the well turns off, water then goes from the reservoir to your home. We call this an in-out system because water travels in and out through the same pipe. And so here we're going to have water traveling to your home from the reservoir. It goes from the reservoir to your home. Then you use the water, whether it's to wash the dishes or wash your hands or get a drink of water. If there's any water left over, it goes down the drain and then it enters the sewer. So it goes down the drain into sewer pipes, and then the sewer pipes take that dirty water, the used water, and sends it to a treatment plant. We call it a WRP, wastewater reclamation plant. At the sewer treatment plant or the wastewater plant, the water is treated, it's cleaned, and then once it's cleaned, it becomes what we call recycled water. The recycled water is not clean enough to drink, but it is clean enough to use on golf courses to water the grass. So what we do with the recycled water from the sewer treatment plant is we actually put it in a purple pipeline and send it to golf courses, and they use it to irrigate their grass. And this is a conservation measure because it turns out grass needs a lot of water, it's pretty thirsty, and we really would not want the golf courses to take water from the aquifer. So this is how we help the golf courses reduce the water they take from the aquifer by taking it from the recycling plant. Now you can see at the right of the screen, you see some water dropping back into the aquifer. If there's any water left over in the system, it's filtered through the soil percolation, and it winds up back in the aquifer. And the cycle is repeated. So we kind of have a mini water cycle here in our groundwater system. So that's how the water gets to your home. Okay, let's check that one off. Okay, how about, source 4, recycled water. We mentioned it. Now I'd like to show you a close-up how that works. It's connected to the sewer system. A little gross, but let's take a look. So here's your bathroom. Say you flush the toilet. The toilet water goes into the sewer, and then it's going to end up at a sewer treatment plant, right? So let's follow the path. Flush the toilet, goes to big pipes that you cannot see because they're buried under the ground. They're called sewer pipes. This is a picture of some of our construction workers working on the sewers underground in the Coachella Valley. So water goes into the sewer pipes. Along the way, there are access points into the sewers. Here's one here. There's an access. It's a big metal lid on there that weighs about 180 pounds. And these guys are construction workers. They can get in there. And if they need to get down there to do inspections and things, they can actually remove the lids and crawl down there to inspect it along the way. So the water's traveling through the pipes under the streets to the treatment plant. Fun fact, I don't know if it's really a fun fact, but here's a question. What does it say on this package here? Yes, flushable wipes. Here's a question. Are flushable wipes flushable? Answer, yes, they are. Another question, should you flush flushable wipes? Answer, no. I know, please do not flush flushable wipes. I know they go nice and easy down the toilet, but you know what? They destroy our system. They do millions of dollars of damage. And here's how they do it. When these flushable wipes are flushed down the pipes, so we say no wipes in the pipes. No wipes in the pipes. They get caught in our pumps. And here's a picture of one of our sewer workers trying to clear out one of our pumps that's been clogged by flushable wipes. Look at this. Oh, gross. All those are flushable wipes. They just destroyed a $20,000 pump. So no wipes in the pipes. Please throw those in the trash. Okay. Now, the water that makes it through ends up here at the wastewater reclamation plant. And the way we treat the water, we actually incorporate these little tiny bugs. They live in the ponds here. You can't see them. They're too small. The only way you can actually see them is under a microscope. In our case here, we're going to use a magnifying glass. And I have a little video here that shows one of our little microscopic organisms treating the sewage. They actually eat the sewage. So there we go. You can see them there crawling along, eating the sewage. And it's amazing to think that these little organisms in our system can treat 18 million gallons of sewage a day. It's incredible. We have billions and billions of these little critters floating around, crawling around, eating the sewage and cleaning it up. Okay? And the way it works is they eat the sewage and they produce a byproduct called sludge. And essentially the way it works is the sludge sinks to the bottom of the tanks. And what it does is it leaves a layer of clear water on top. So all we have to do now is separate the sludge from the clear water, and voila, we have recycled water. So we have vacuum pumps that actually suck the sludge away. And then we actually dump the sludge into trucks. And the trucks haul the sludge away to a composting facility. And there they mix it with lawn cuttings and tree cuttings and things like that. They mix it up and they compost it and they turn it into fertilizer. And then it can be used for gardening or farming, things of that nature. So that's the sludge. We take that away. Now, the clear water actually is separated, goes through a filter, and once it's filtered, we add some chlorine to it because the chlorine will kill any bad bugs that are in there. That's for your health. We kill off any of the microorganisms that are left. And what's left, what the product is what this guy is holding in his hand. This is what recycled water looks like. It almost looks like you could drink it. It is that clear, okay? It is not drinkable. So we put this recycled water into purple pipes. So everybody knows that if you see water coming out of a purple pipe, it is recycled water. Do not drink it, okay? It's okay if you get it on your skin. It's not going to hurt you. but don't drink it, okay? And it's okay for irrigation. You can use it to water, say, the grass at the golf courses. That's where we send it. And there you go. Golf courses using recycled water. So now that we understand that, let's check that off our list. But before we check it off our list, let's look, another pie chart. I think this is my last pie chart. This is the one that shows how we've been conserving water over the years by sending recycled water to golf courses. Okay, let's take a look. We're going to start in the year 2006. On our pie chart here, we're going to use the golf ball as a template. The blue is going to represent aquifer water, and the purple is going to represent recycled or alternate water. Okay? So 2006, there we go. We have 88% and 12%. In 2006, 88% of our golf courses used water from the aquifer. Okay, not good. So we started building pipelines to reach out to more golf courses so we can get more recycled water out there. And here's where we were in 2018. 2018, we now have 55% of golf courses on recycled or alternate water and only 45% on aquifer water. And here's what we expect it to look like. When we reach this goal, this is absolutely what we call sustainable. Okay, so this is an important goal for us to reach, and we believe that we will definitely reach that goal. Okay, can I check it off the list now? Yes, there we go. Last one to check off the list is canal water. Have not talked, I don't think I've talked anything about the canal. But here in the Coachella Valley, we have a canal that runs through our towns and our cities. It is from the Colorado River. This is water that we use for farming, for golf courses, and for percolating back into the ground. There's a picture of it. Perhaps you've seen it as it runs through the towns of this area here. Please never swim in a canal. Canals are dangerous. I hate to say it, but people die all the time in canals. The current is very swift. The water is cold. It is deep, and even good swimmers get pulled under and drowned. Stay out of the canal. No nades. No swimming. Okay. To give you a bird's eye view of the canal, I'm going to put it in our map here. So there's our map. You see the CRA, the Colorado River Aqueduct, that runs from the Colorado River through the Coachella Valley. Now, here's the canal system, the Coachella Canal system, as it comes into the Coachella Valley. You can see it comes in from the southern portion of California there, flows north into the Coachella Valley. That's how it gets here. Okay, that's the canal. And there's our four sources of water in the valley: groundwater, canal water, state water project water, and recycled water. Okay. Quick review. 1, fresh water is a limited resource. How much water on the earth is available as fresh water? 1%. Yes, a lot of water on the earth, only 1% available, fresh water. We talked about this 1% fresh water is constantly recycled around the globe in a natural process called the water cycle, powered by the sun. So that was the good news of this, that even though we have only 1% available fresh water, it is constantly moving around the earth and giving us a constant supply of water. Here in the Coachella Valley, we get our water from 4 sources. 1, groundwater. 2, canal water from the Colorado River. 3, state water project water that we trade with the Metropolitan Water District. And 4, recycled water, which we use mainly for golf courses. Now, something as equally important as canal safety, I haven't mentioned it, is conserving water. So I haven't talked about it yet, but let's just look at a few ways we can conserve water, and then we'll wrap it up. Turn off the water when you brush your teeth. You know, if everybody in the valley did that every day, twice a day, we'd save 1 million gallons a day. So a little bit goes a long ways. Turn off the water when you brush your teeth. Try to take shorter showers. You know, if you can take a 5-minute shower instead of a 10-minute shower, you're going to save about 25 gallons of water. Take a 2-minute shower, save even more. Fix those leaky faucets. A leaky faucet can lose up to 5,000 gallons in a year. When you wash the car, make sure you use a bucket and a nozzle. Put a nozzle on the end of the hose, hold the water in the hose until you're ready to use it. When you're washing dishes in the dishwasher or washing a load of laundry, only wash full loads, okay? Because if you only wash a half load, you still have another half you have to wash. You just ran 2 loads you could have done in 1. So, okay, conserve water, check. And I'll say it one last time. When it comes to the canal, you see the canal, stay out. Stay alive. And that is the end of my presentation. Thank you so much for listening. Goodbye.